Welcome everyone to the FIAS December office hours. This month, we are so excited to welcome Allison Biles, who started Energy Vanguard, which is a HERS training provider, HERS QR provider, and a BPI test center. He is most known for publishing the Energy Vanguard blog and writing a weekly column for Green Building Advisor. We are so excited to have him here. He will juggle your questions, and if we're lucky, he might juggle something else. So take it away, Allison, and thank you so much for coming.
Oh, well, thank you for that introduction, and I'm happy to be here. So I think we've got this figured out now, how to share it and make it work right away. Let's see if I can do it this time. Come on,
Just a
come
quick
on.
reminder, if participants have an additional question, please put it in the chat and we'll make sure to address it
Where did it go?
as we go.
All right, I am looking for PowerPoint. Where are you? Oh, there you are. Okay, PowerPoint. Share. All right, did that work? Are you
It
seeing
worked
the title
beautifully.
screen?
Yep.
Okay.
Good.
So this is the fanciest slide of all, because the rest of them are just questions. Make this a little easier on myself rather than putting together a whole presentation, a real presentation. So now let me click up there. And for those of you who may not know me, I am in the Atlanta, Georgia area. So not a cold climate, but we in our business, we do a number of things. One of the well, this year especially, it seems like one of the biggest things we do is HVAC design, residential HVAC design, including for some passive houses. And we don't do a lot with passive house. I am on the board of FIAS. I have been since 2013, but I've never taken the training or done any kind of certification stuff. So and I all of you probably know the standard way better than I do. I know a little bit about it, but I do know something about mechanical systems, HVAC. So we'll talk about that. And let's see. You see the first slide with the question. Okay. Woohoo! Wow. It took me, I think, at least 5 minutes 2 weeks ago when I did this to make this work right. So okay. So first one here. Let's talk about dehumidification. So the question is, do you recommend supplemental dehumidification for low load homes and mixed humid climates? So, and the answer is yes. All right, next question. No. Let's talk about that a little bit. So, I live in a mixed humid climate. Atlanta is mixed humid. We have hot weather in the summer and we have humid weather, but we also have some cold weather. I mean, not like you in Canada or Maine, but the the number of heating degree days we have here in Atlanta is about 3,000 on average. Well, it used to be anyway. The last decade is we have not averaged 3,000, I don't think. But so we do get some cold weather. Our design temperature is 23. Our winter design temperature is 23 Fahrenheit, and so we have some cold weather, but we also have humidity. Not as bad as Florida or the Atlantic coast, like Charleston, or the Gulf Coast, New Orleans, Houston. But we have some humidity. So in a mixed humid climate, you could go either way. You can almost get away without a dehumidifier, depending on what your comfort level is with humidity. And especially in a passive house, you're probably going to want a dehumidifier, supplemental dehumidifier, because in a passive house you have reduced the latent load significantly, and I'm sorry, you have reduced the well, you've reduced both. You've reduced the sensible and the latent loads significantly, but the ratio of the sensible and the latent loads has changed more, and so you end up with a house that has fairly high sensible heat ratio, which is the ratio of the I'm sorry, uh, yeah, a fairly high, well, I'm sorry, a fairly low sensible heat ratio, which means that the latent load compared to the sensible load is higher, because you've cut down a lot of the the sensible heat gain through the walls, the ceilings, the floors. The enclosure is really, really good. You've cut down a lot of the sensible heat gain, and now with the infiltration, the air sealing that you've done, really low infiltration, you've cut down a lot of the latent load too. But the ratio um, is changed, and that's why you you still need some kind of dehumidification, I think, even in a mixed humid climate. The other thing is we still don't have air conditioners small enough. Um, uh, and I deal with this all the time. When we have to deal with zones that have a load, a peak load of 2,000 BTUs per hour, uh, for example, and we have equipment that uh, goes down to, well, the peak capacity of it is about 6,000 BTUs per hour. Now it modulates down to maybe a quarter of that, and so it'll go down to about 1,500 to 2,000 BTUs per hour when we're talking about variable capacity mini splits, inverter driven compressors and all that. But um, the uh, the capacity of 1,500 or 2,000 BTUs per hour with a load of 2,000 BTUs per hour means that you're always going to be pegged at the bottom of the capacity range. So you're not getting much benefit from the variable capacity feature of your equipment because you're always pegged at the bottom. If your peak load is 2,000 and your minimum capacity is 2,000, um, and remember, your peak load is not where you are all the time. Most of the time, you're at less than peak load. You're at part load conditions. So you've got, maybe 1,000 BTUs per hour, 500 BTUs per hour of load, and a 2,000 BTU per hour minimum on your equipment. And so even with mini split equipment, you're not going to get the runtime that you need to dehumidify properly. So supplemental dehumidification. And then there are the days, and there are plenty of them in mixed humid climates, even in the wintertime. I wrote an article in January of this year, I believe, about the perfect weather for a dehumidifier, because we were in January having 70-degree weather in Atlanta, and it happens occasionally here. Um, 70-degree weather, and too cool for the air conditioner to do anything really. And if it's 70 degrees and high humidity, so on gray, rainy days when it's 70 degrees out, the humidity in the house can get very high and uncomfortable. And if it stays that way long enough, you can grow mold. So supplemental dehumidification is the way to deal with that. So yes. Okay. Second part of this question, this is a three-part question. So the second part, the person asked, if so, what's the best location for the dehumidifier? Now, there's actually two parts to this, because the dehumidifier is the unit itself, but we usually do, in our design, we usually specify ducted dehumidifier. So it's not just where the actual dehumidifier is, it's where the dehumidifier is pulling air from and putting air back into the house. So one thing you have to be careful of is where you're putting that air. When you dehumidify air, a dehumidifier is basically like an air conditioner, and it has a compressor. It has two coils, the evaporator coil and the condensing coil. With an air conditioner, though, the air that passes over the condensing coil goes outdoors, or is outdoors. Depends on whether it's a window unit or PTAC or split system. And the evaporator coil, the air that goes over the evaporator coil, goes indoors, and that's air coming off the evaporator coil is cooler and drier. The air coming off the condensing coil is warmer. But with a dehumidifier, both of those air streams are going back into the house. So the air coming out of a dehumidifier is warmer. And so you need to be careful with where you're putting that warm air. Um, it's like ventilation. If you've ever dealt with ventilation issues where you had a house where somebody put the HRV or ERV supply vent in a bedroom and it's blowing right on the bed, and people complain about cold air blowing on them. Ever heard of that before? So you don't want to blow cold air on people. You don't want to blow hot air on people. In fact, a general rule, with the exception of ceiling fans, is you don't want to blow air directly on people. With your heating and cooling system, you want the air to mix in the room and not hit the people directly. So with the air from a dehumidifier, the best thing to do is dump it somewhere where it will be well mixed in the room before it gets to the people. So it's drying out the air, but it's also tempering in temperature by the time it reaches where the people are, the occupied zone. Um, I was just working on a design this week for a house where we um, put a dehumidifier in, and it's a two-story house. The second story has an open to below area, and so I have the dehumidified air blowing into the space over the open to below, and then there's return. The return for the dehumidifier is in the loft area, the rec area near that, and there's also other returns. So that will help um, temper the air before it gets to where the people are. So you got to think about that. Where the actual dehumidifier unit is, if it's ducted, doesn't matter that much. Probably want it, well, you definitely want that somewhere where noise won't be an issue. If you put it in a closet with a regular hollow core door, you might have some noise issues with that. So you got to consider the noise. All right, let's see here. Next part of this question, should it be tied to the heating and cooling ductwork for distribution? The best way to do ducting for a dehumidifier, and this applies to an ERV or HRV as well, in my opinion, is to have completely separate ducts. Just don't try to tie it in with the ducts for the heating and cooling system. That's in the design that I was working on this week. That's what we did. It's best to have everything with its own duct system. Now, you can't always do that. So if you are going to tie it in with the heating and cooling system, there's a couple things to know. One is the best place to put the dehumidified air is into the supply air duct, into the supply plenum or the supply trunk line, and send it out into the house through the supply duct. Some people want to put it into the return side because it'll go through the air conditioner and it'll get cooled directly through the air conditioner instead of just being tempered with the supply air on the other side. But here's what happens if you put it on the return side. Now the air being pulled in to the evaporator coil in cooling mode, and which is usually when you're going to be running the dehumidifier, is drier. So the air conditioner itself is not going to be doing as much dehumidification because it's getting drier air, which means your dehumidifier will run more. So the best place to dump that dehumidified air is on the supply side, where it gets tempered with the supply air before it comes out. The supply air coming out will be a little bit warmer. The other thing you have to be very aware of is how much air you're putting in there. If you've got a dehumidifier with an output of 600 CFM, that would be a big dehumidifier. And you're putting that into let's say a 2-ton air conditioning system, which you're not going to have in a passive house, but let's say 1.5 ton. You've got a conventional 1.5 ton system. You're putting in 600 CFM of dehumidifier air. You are adding the same amount of dehumidifier air to those ducts as the air going through the air conditioner. So you've got to, well, not a good idea, because the air coming out will not be as cool. It's better to split that up some kind of way. Maybe find another place where you can dump some of it directly in a place where it's going to get tempered before it reaches the people, and um, put a much smaller amount into the supply airstream. Now, uh, having said the best place to put your dehumidified air is into the supply ducts, you can't always do that. You have to check the dehumidifier specs because not all of them are capable of doing that. Some of them need to go on the return side. And the when you do connect the dehumidifier duct to the heating and cooling ducts, there's different ways of doing it. So one way is to have a dedicated return or intake for the dehumidifier, and then put the supply of the dehumidifier into the heating and cooling system, either on the return side or the supply side. Supply side ideally, return side if you can't. Uh, and there's another method called the injection method, where you put both the intake and the supply ducts for the dehumidifier on either on the return side or on the supply side. So it's pulling air. Let's say you put it on the return side. It pulls air from the return into the dehumidifier, and it dumps air back into the return. So you probably see a problem with that already, a potential problem. The problem is that if the system's not running, you could just short circuit and just be dehumidifying the same air over and over again. So if you do that, this is called the injection method, with both the intake and the supply on the same side. What you have to do is tie the compressor, the dehumidifier's compressor electronics into the controls for the blower on the air handler. And every time the dehumidifier comes on, the blower on the heating and cooling system has to come on, because that will cause more air to move through there, and then that prevents the short circuiting of the air. So you've got to have those controls tied together. When the dehumidifier comes on, the blower comes on. Uses more energy that way as well. So, so the number one solution is separate ductwork completely. If you're going to tie it in with the heating and cooling system, put it on the supply side if you can, with a separate intake. And if not, put it on the return side. And if you use the injection method where both are on the same side, you have to have the controls tied together so the blower comes on. That's the rule there. All right. Here's a good one. Tell us about ceiling fans. When are they actually useful? When are they psychologically useful? Oh gosh, this is a great question for Robert Bean. Robert Bean is the guy from Calgary. He was on the ASHRAE Standard 55 committee and knows all about comfort. I imagine most people here probably have heard of him, or maybe have been to his presentations. He talks about, and pretty much all his presentations, I think, he talks about all the receptors in the human body and in our skin that perceive the temperature and the air movement and all these different things, gazillions of them. And he's got actual numbers, I think. I don't remember what they are, but this is really a question about comfort. And so the number one thing about ceiling fans is they cool people. They don't cool the air. They actually heat the air slightly. I mean, they add not a whole lot of heat, but whatever the efficiency of the fan is, that all the electricity that goes into that fan, all the electricity used in that fan turns into heat in the room, every bit of it. So if you have your fan on and it uses 5 kilowatt hours of electricity a day, that 5 kilowatt hours turns into heat. All of that turns into heat that goes into the room. So that's the number one thing that a lot of people don't understand about ceiling fans. So they're mainly useful when the air is blowing over people, because, and that's in the summertime when you want to cool off. Well, actually, we're always cooling off. Our bodies need to cool. We have an inner core temperature, which used to be 98.6, but now I can't remember what the number is, 97 point something, I believe. That news came out in the past year, I believe. The 98.6 number is based on old data, and we know better now that the human body is actually cooler than that. But anyway, we're 97 point something degrees inside, and our body is constantly having to cool. We have this heat being generated because of our metabolism. We have to cool off, and in summer we really feel that because the conditions around us are warmer. In wintertime, it's easier to cool off because the conditions outside our bodies are cooler, and we we have to wear clothing to keep from cooling off too much. So fans are useful when they're blowing across our skin on a warm day and can help us to cool off. They're psychologically useful. Well, gosh, that's a more difficult question. There's for some people they're psychologically useful when they are running all the time, it appears, because yeah, I walk by houses sometimes and the ceiling fans on the porch are on 24/7, and there's almost never anybody on the porch. So maybe they're psychologically useful in some way, I don't know. Anyway, let's go to the next question.
Allison, I have a question in the
Yes,
chat
sure.
about a secondary humidifier. Would a secondary humidifier be useful in a cold, humid climate like northern New England?
Secondary.
Dehumidifier.
Sorry, I can't
Trying to
read.
use for a dehumidifier in a climate, say like Maine, where there's a lot of humidity in the summer actually, and we do have some stretches of hot weather.
Mhm. Yep.
So,
And
and
Chicago.
secondary question is, I assume these dehumidifiers have a condensate drain.
Yep.
It has to be piped somewhere.
Yep.
Okay.
Yep. So the dehumidifiers that we spec are the ultra air dehumidifiers, and they're not a sponsor of Energy Vanguard right now, but they have advertised in our blog, so I'll throw that out as in full disclosure. April Air makes similar dehumidifiers, and those are the two main brands that you see in homes, I think. So the question, let's see, so do you need a supplemental dehumidifier in a place like Maine in the summertime? It depends. I mean, you're not going to use them as much there as in the South, but if you I have been in Maine on warm days, and I know more people in Maine are getting air conditioners, but there's still quite a few houses, I believe, that do not have air conditioners. And without an air conditioner, you have no means of dehumidifying. The thing about adding a dehumidifier to a house without an air conditioner, though, it will heat up your house. So on those warm days, when warm, muggy days, when you're trying to dry things out, it'll also heat them up. So it'll make your house less comfortable in a way. You'll have more sensible heat. So, and what was the second part of your question?
No, you answered it, just about
Okay.
condensate drain.
Oh, okay. Condensate drains. Yep. Yeah. They make water, and oh yeah, that's where I was going with the ultra air. So yeah, I mean, when we're talking about the kind of dehumidifiers that you duct, they have condensate drains, so they can either drain by gravity or into a condensate pump and be pumped out. But they do not have the buckets that you have to empty. The little standalone dehumidifiers that you see sometimes have the buckets, but they can also be hooked up to a drain. All right. All right. So next question here: which is better, ductless or ducted mini split heat pumps? My answer is both. They're both great. I like ductless mini split heat pumps. Their efficiency ratings are definitely higher, and they They can do the job very well in places in areas that are open. So ductless mini split heat pumps are great for open areas where people don't mind the looks of them. There are plenty of people who don't want to see those things on the wall or on the ceiling. Uh, there are, by the way, there are different, I'm not sure everybody here knows this, but they're not all wall mounted units. You can get ductless mini split heat pumps that um, are set into the ceiling. There, Mitsubishi makes two different kinds of ceiling cassettes. One is a four-way square uh, heat pump ceiling cassette that blows in four directions. The other is a one-way rectangular unit that goes between 16-inch on center joists, and it blows in one direction. And you have floor-mounted units. So there's other options for ductless besides just the wall-mounted units. And what I like for ducted mini splits is bedrooms. So the same job that I was telling you about, the dehumidifier earlier that I was working on this week, he wanted to go with all ductless units, and he came to me. It's a 3,000 square foot house in North Carolina, and he had scoped it out, and he thought he needed 8 ductless mini splits in the house. He wanted one in each bedroom. I think he wanted one in the kitchen, one in the great room, one in the rec area, and one in the bar. And the total load on the house was 2 tons for the whole house. So I talked him out of 8 zones. And I also talked him out of individual ductless units in the bedroom. So we put a ducted system. So upstairs there's 2 bedrooms, downstairs there's 2 bedrooms. So I set it up with one ducted mini split for each of the 2 sets of bedrooms. So I like both ductless and ducted. The ductless system, or I'm sorry, the ducted systems, one thing that a lot of people get in trouble with is going with the low static units and not doing the ducts correctly. If you use the low static units, which are, the blowers aren't as powerful as the conventional systems, and so you have to have a really low resistance duct system, because these things were made for actually very short duct systems, where one side comes out and it goes straight into a return, and the other side is just blowing straight into the room. This is made for like a one room or kind of a studio apartment kind of thing, or a hotel room kind of setup. And when you start putting more ducts on these things, you have to be careful, because you can run into problems with too much resistance and not getting the airflow that you need. But that's not a given. I've got 2 low static ducted mini split heat pumps in my attic with plenty of ductwork on them. I've written about this in our blog. Lots of ductwork on them, and they're rated for. We're going to get a little technical with the static pressure stuff, but they're rated for 0.2 inch of static pressure. 0.2 inch of water column is the pressure unit. A typical conventional furnace or air conditioner is rated for 0.5, and these are rated for 0.2, so significantly less pressure available to push the air through the ducts. And our 2 ducted air handlers are running at, when I checked this summer, one was at 0.13 and the other was at 0.14. So you want to keep it less than 0.2. We got 0.13 and 0.14, and that's with MERV 13 filters attached as well. So let's see what's next. What is your opinion of air to water heat pump systems, AWHP, in cold climates? Well, let's talk about air to water heat pump systems in any climate. So in our design, we just do air distribution. So if somebody wants hydronic distribution of any sort, whether that's in-floor radiant or radiant wall panels or ceiling panels, we send them somewhere else because we don't do that. The radiant systems can be very, very good. And my friend Christoph Irwin in Austin, Texas, is a big fan of those. And I don't know how much he's doing with them in his business lately, but Robert Bean, also a big hydronic guy. And so air to water heat pump systems. So let's back up and explain what this means. So if you have a heat pump, you've got two pieces. Let's split system heat pump. You've got two parts. You've got the outdoor unit, and it's exchanging heat with the outdoors, either air or water or ground. And you've got the indoor unit on the inside of the house, and that's exchanging heat with the inside of the house, either through air or water. So air to water heat pump systems means that the outside part is using air. So the refrigerant goes to the outdoor unit and it's blowing air over the coil. So it's in summertime, when you're trying to get rid of heat from the house, it's putting that heat from the house into the outdoor air. And then on the inside, the water part, the heat exchange that happens on the inside is transferred to water. So the evaporator coil inside is connected with a hydronic system that is in summertime cooling the water going through the system, and wintertime it's heating the water that's going through the system to either baseboard radiators or radiant wall panels or hydronic tubing in the floor, whatever it's going to. So the air to waters, air exchange on the outside, water exchange on the inside. So these systems can work very well. Hydronic systems are not my forte, so I don't know a lot about that. In cold climates, I don't see why it wouldn't work fine in cold climates. Air source, so this would basically be an air source heat pump. It's just that on the inside of the house, you're doing hydronic distribution instead of air distribution. And air source heat pumps work well in cold climates. Oh, I should have put that picture in here. I've got a picture of Gary Nelson, founder of the Energy Conservatory, maker of the Minneapolis blower door and duct blaster, with his 1.5-ton Fujitsu ducted mini split heat pump in his, I think it's about a 2,500 square foot house, and it heats it just fine. Even a couple of years ago, when they got down to about minus 30, I think, the house, he was in Australia at the time, but he's got everything hooked up with sensors and was monitoring everything. And the house, I think it got down to 59 degrees or something. But he said if they had been home, their body. So first of all, they've done a lot of work on the house. They did a big renovation on the house. They've got lots of insulation on the walls. They've got triple pane windows, and this is in Minneapolis, so it gets cold. And is really airtight, as you would expect from the guy who came up with the blower door, the Minneapolis blower door. And he said if we had been home, our body heat and just baking some cookies or something would have brought the temperature back up to 70. Air source heat pumps in cold climates can work just fine, whether they distribute the heat inside through water or through air. Are there any air to water heat pumps using CO2 as the refrigerant? So this is a good question. I don't know a whole lot about refrigerants. There's a lot about refrigerants, but one thing that I have heard from a guy who works for a manufacturer is CO2 will probably never be used in space heating systems as a refrigerant, because the critical point is at 88 Fahrenheit, and what happens is, so in a regular air conditioner or heat pump system, the really important exchange that happens is a phase change. So in the evaporator coil and in the condensing coil, you have a phase change that happens, and phase changes can absorb and transfer a lot more heat than just temperature changes. For example, when you think about water, to heat a pound of water from the freezing point to the boiling point, from 32 Fahrenheit to 212 Fahrenheit, 180 degrees Fahrenheit. It takes 180 BTUs to heat that up. And when you get to the boiling point and you boil that pound of water, so it took 180 degrees to heat it up from freezing to boiling. When you boil that pound of water, it takes 970 BTUs of heat to do that. So there's bigger heat exchanges and phase changes than there are in temperature changes. And that's why, refrigerants are tricky, because you've got to find something that has phase changes in the right places, that will work for the temperatures that we're dealing with. And CO2 does not work that well for space heating because of that critical temperature being where it is. So because then your heat transfer on the inside part is happening just with the temperature change, not with the phase change. Now, with water heating, that's different, because the transfer that's happening inside, let's see, I'm probably going to mess this up. Well, let me not try to explain that, but it does work for water heating. And we know that because there is this company called Sandon, which many of you have probably heard of, maybe used their product, which makes heat pump water heater, a split system heat pump water heater. And I think, is that my next question? Oh yeah, here we go. What is the best residential water heating option for cold climate homes? So this is a perfect segue. So the Sandon water heater is a split system water heater. It's a split system heat pump water heater. So just like with a heat pump for heating the space inside a house, it's got an outdoor unit, and the outdoor unit looks a lot like the outdoor unit for a mini split heat pump. It's small and relatively narrow and quiet, and it's connected to the tank inside the house. So it's pulling heat from the outdoor air and putting it into the house. So I would say the Sandon water heater, Sandon's the only company I know of that makes something like this. Maybe there are others now, but the Sandon water heater, which is a split system water heater, is great, I think, for cold climates. And I don't know how cold it works in. The only one I've seen in real life was in Seattle. Seattle's not cold. They're cool, but it's
they're similar. We just put one in a passive house in Chicago area, and it's good down to like 20 below or something.
Oh, okay, good.
Yeah.
That's good to hear. Yeah. So yeah, that's your best option for water heating and cold climates then, because you can use a regular heat pump water heater as well. And Mark Rosenbaum in Massachusetts is a big fan of those, and says that even though they do cool the inside of the house, they are still a benefit to the home. So with the heat pump water heater, you're pulling heat from somewhere. If it's a self-contained unit like the one that I have in my basement where I am right now, it cools the basement. So in wintertime, in summertime, that's a good thing. And in wintertime, it's not such a good thing. It can cool things off a little bit. But the other thing is, it depends on how much hot water you're using too. The amount of cooling that you're going to get in the house is tied to how much hot water you use. In a house with two, and I'm in this house with just me and my wife, so most of the time we're not using a whole lot of hot water, so we're not getting a whole lot of dehumidification benefit from our heat pump water heater, or a whole lot of cooling from it. Either one of those, any kind of heat pump water heater is what I would recommend for for any climate. I love heat pump water heaters, and for cold climates down to -20, according to Tom, the Sandon water heater is your option for not cooling off the inside of the house. All right. What else we got here? Do you see value in using ground loop ventilation preheat with North American ERVs and HRVs units that are capable of defrosting? And this is a question I don't know a whole lot about, but I know Martin Holliday has written about it, and yes, I think they can work fine. What this system is so you've got loops buried in the ground, and there's a glycol solution circulating through the loops. The loops go around the ventilation ducts, bringing outdoor air in. So in the wintertime, you preheat that air because the ground, of course, is warmer in winter than the outdoor air. So when you've got, let's say, 0 degree Fahrenheit air coming through the ventilation duct, and you've got these ground loops, if you're 5 feet below the ground, 4 or 5 feet below the ground, the temperature is going to be close to the average temperature of that area, and significantly warmer than the outdoor air. So these ground loops can circulate this glycol solution, put the heat exchanger with the duct bringing the outdoor air into the house and preheat it. That saves some energy on defrosting and keeping things from breaking down. So, but you're also using energy to circulate that glycol solution, and it's a more complex system. So see Martin Holliday's article. If you go to Green Building Advisor, I think it's sometime in the past 5 years, he wrote about that. Let's see here. For buildings which are in locations which do not require a full cooling system, what are your thoughts on providing single wall ports for occupants to hook up portable air conditioners if they want some cooling? Not wall shakers, but the $500 small units. That's a good question. I had never even considered this before. So is this your question, Alan? It sounds like something from Maine. So a portable air conditioner could work. So with a portable air conditioner, you have to have a connection to the outdoors. And what a lot of people, you see these used on construction sites and on renovation jobs, and they usually open a window and run the duct out the window and then seal up around it. But you don't want to do that normally, probably. So should you put a port in the wall, and I guess put a plug of insulation in there for the rest of the year when you're not using it, I guess. So I don't have strong thoughts on this. I like air conditioning, but I live in the South, and so it depends on how much you really want that cooling, and how can you do this in the best way possible so that your house is just as tight even with that port, and just as well insulated even with that port when it's not being used. So let's see. How does a ground source heat pump compare to air source for performance, cost, and efficiency? Gosh. So for cost, I can tell you that ground source heat pumps are more expensive, and the main difference is the ground loops, the wells or the horizontal loops, because you've got and I called them wells. The ground source heat pump industry calls them boreholes, not wells. And boreholes always makes me think of a book that I read a long time ago called what was it called? Eccentric Notions and Strange People, or Strange Notions and Eccentric People, something like that. And it's a really interesting book. There's a chapter about a guy who invented a battleship made out of ice, and nobody ever built one. But the borehole thing reminds me of the chapter on trepanation, and I don't know if you know what trepanation is. It sounds interesting, and apparently in ancient cultures in some places they used to do this. Trepanation is drilling a hole in your head, and there are people within the past century. I don't know if they're still around now, but there are people in the past century who have actually done this. They've taken a drill and drilled a hole in their head because they say it relieves the pressure on the brain and it makes you feel like you're on acid all the time. I don't think I'd want to feel like I'm on acid all the time, but apparently they like it. It gives them a euphoric feeling. I don't know. Trepanation, look it up. Borehole. One person wrote a book or made a film called Borehole. That's why I always think about. That's what I always think about when I hear people on the ground source heat pump talking about boreholes. So anyway, there you go. There's your extra information for tonight that you weren't expecting. So anyway, yes, the ground source heat pumps are more expensive without tax credits, which I don't think we have them anymore, unless I don't know. But the tax credits is what made them so popular, because in the U.S. there were tax credits for a while, and that basically paid for the drilling or digging that you had to do to get the loops in the ground. And so they were competitive cost-wise because of that. Performance and efficiency, they're fairly similar, I think. I like mini splits because they're simpler. Air to air, I think, is really super efficient. Inverter driven compressors have made all the difference. And now that we have that, why bother with more complex and expensive technology? That's my opinion on that. Yes, I do try to talk people out of ground source heat pumps. Don't tell my friends in the industry that, though. Hey, look at that. That was the last question I've got. So did you come up with anything else in the chat?
Oh, we do. Chris, would you like to ask your question? Because I'm afraid.
Okay, just a second here, getting myself off mute. Yeah, so I've been asked to do a design. I'm HVAC technician, whatever. For a small commercial type building, it's going to be used more or less a community center. So it's about ventilation, and it's going to need around about 450 CFM, but only in peak mode, and it's going to need to quiet down a lot. And I like to use very efficient units, ERVs, and so I can't get up here something right size that's really efficient. So I was wondering about ganging smaller units, very efficient ERVs. And it typically would be like a simplified connection, or I think you used the term injection system, injection connection. So could I gang a couple smaller units to a simplified connection, and then probably gang them in parallel? Would that make sense to you? Would there be potentially some issues keeping them balanced, running parallel like that?
Oh, that's a good question. I think that should work fine. It would require a lot of attention during commissioning to, make sure your airflows are working and the controls are working the way you want. And but yeah, I think that should work fine.
Cool, thanks. I realized it's an ambush.
I had emailed in some questions that I guess didn't make the list.
Oh, you're the one who sent those questions.
Yeah.
Which ones?
And now I'm trying to remember what they were, and I just looked for my email. I couldn't find it. Dang it! But I think.
Do you remember what the topic was?
Yeah. It was about when you said the general thing that about using the wall hung mini splits or the ductless in open areas, not in bedrooms, or not for closed rooms. I guess I'm wondering if there's like a design temperature at which you wouldn't be worried about putting one in the middle of a house, if the house is compact and you have the bedrooms cut off. Sorry, I'm really tongue-tied right now. You don't like
Well, so yes, there's a builder in Massachusetts who builds zero energy homes. What was his name? He spoke at Building Science Summer Camp a few years ago, and Martin Holliday's written about his houses. So he builds these, I don't know, 2,000, 2,500 square foot, 2-story houses in Massachusetts. And when he first started doing these, so zero energy, so super insulated, really airtight, very low loads. And when he first started doing these houses, he was doing them with one ductless unit on the first floor, I believe, and that's plenty to handle the load for the house. And in wintertime, if it's on the first floor in wintertime, that was fine because the warm air rises but he found that it worked better to have 2 units, even though, with 2 units, there was more capacity more capacity than the house needed, but just for the distribution. But it was still 2 ductless units. He did not have any fans distributing air to the bedrooms, I think. But so, yeah, I think it can work fine. I think, it depends on people's expectations too. I grew up in houses, not, see, and some of the houses I grew up in had just a, window unit air conditioner. I'm talking about South Louisiana with just one window unit air conditioner, about I don't know, 1,500 square foot house. And, it would run all the time. And it eventually would cool the farthest parts of the house. And also in Florida, I lived in a house that had a window unit for a 3-bedroom house. And, once the house gets cooled down, it does get out everywhere.
I have a few more questions in the chat.
Mm-hmm.
Do you endorse the HRV, ERV pull from bathrooms and a kitchen with a recirculating hood and carbon filter above an induction cooktop?
Well, I'm not crazy about it. I know it's big in passive house because you want to minimize the penetrations through the enclosure and try to do as much as you can with your ventilation system. One problem that I have with that is, if you're using an ERV and you're exhausting from the bathrooms with an ERV exchanges heat and moisture. And one of the biggest reasons for exhausting from a bathroom is to get rid of the moisture. But if you're using an ERV, let's say half of the moisture is going back into the house. You're getting rid of half of it, but half of it's going back into the house. So that's probably my main objection to it. I think it can work okay, but I usually try to tell our clients to put exhaust fans in the bathrooms. And regarding the kitchen, again, I'm partial to range hood that vents to the outside.
Thank you. And this will be our last question so everyone can get it out on time. Do you have recommended supply air rates for your rooms?
Supply air for heating and cooling, supply air for ventilation, for...
Steve, do you want to unmute yourself and clarify your question?
Yeah, for ventilation.
Ventilation.
Yeah.
No, we don't have any hard and fast rules on that. Generally, probably 20 to 30 CFM for bedrooms.
Theus has done a good job of doing the exhaust rates. We got to satisfy. I just really struggle to make sure I'm getting adequate ventilation to the bedrooms. And like, what about a great room? Kitchens. And again, what you were just talking about for range hoods, for makeup air, things like that. It gets to be a real struggle when you try to balance that out with the energy use we're trying to satisfy as well.
Yeah. The main thing that we concentrate on is, the overall ventilation rate for the house, and then distribute it mostly to the bedrooms, but put a little bit of the supply in the living space. So mostly the bedrooms, because in the bedrooms, if people are in the bedrooms at night and the bedrooms are closed, you want fresh air going in there, because the CO2 levels can go up, and that makes you have nightmares. And then you wake up and you're all sweating and their blankets are all over the place.
That happens. Hey, Allison, if I'm not interrupting, Jenny found my question, and this is one that I wanted to ask you about. It seems like a lot of our projects we're running like 2-story. We've got like a ducted mini split on the second floor for the bedrooms and a ductless on the first floor. Mm-hmm. We could do them with 2 separate outdoor units, or we could do them with a single multi-zone. And my question was regarding that and how far down they modulate. At what point are you concerned about losing efficiency and you just use separate single zones? Any other issues with manifolds and all that stuff?
Yeah, so we try to talk all of our clients into going to all one-to-one systems if possible. That's not always possible. We've got a client in the DC area who's got it's like a 4-story townhome, and there's just not enough room for the 6 systems that 6 outdoor units I think he would have to have. So sometimes we have to do multi-splits, but we try to do one-to-one as much as possible, because it's more efficient, and you don't have the likelihood of the chance of comfort problems, because with the multi-splits, the refrigerant can flow to the units even when they're not calling for air. If one's calling, then the refrigerant can sometimes go places where you don't want it to.
I hate to do it, but I must cut us all off. We've reached the top of the hour, as they say. Thank you so much, Allison, for your time and consideration, and thank you everyone for submitting questions and coming to this presentation. So thank you, and everyone has a great night.